Pastor Lodri. Hello there, I'm Thomas Hatsios, German-American pilot flying the Boeing 787-900. Tonight's flight we're gonna be over from Zurich, Switzerland, Germany, then coming back to Zurich International over runway 1449 Lszh localizer and landing soon. I'm in the cockpit for the pre-takeoff preparation of the quality wings Boeing 787-900 and Microsoft Flight Simulator X. I'm gonna start with the cockpit instruments and displays and the functions of the Boeing 787-900 jet aircraft. I'm gonna start with the primary flight display. The displays are the airspeed indicated, the airspeed selected from the autopilot flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the target altitude selected from the autopilot flight director system panel, the barometric pressure of the outside atmosphere, the vertical rate of climb distance of the aircraft in tens, hundreds, and thousands of feet per minute, all the stability, the trigonometric angles increase and climb and descend. We have also the Lszh localizer, the horizontal localizer in the artificial horizon and the other indicator of the pitch ladder degrees, the bank angle degrees, the Lszh localizer, the horizontal localizer, and vertical glide slope. You can see the Lszh localizer information from the receivers of the aircraft receive the radio frequency transmitted from the threshold antennas of the instrument landing system of the Lszh localizer. So we're gonna use the Lszh localizer of the Zurich International Airport Lszh in Switzerland, both for takeoff and for landing. You're gonna see the Lszh frequency of the Zurich International Airport Lszh displayed. So we have also the Lszh localizer crossbars, the flight director crossbars for manual guidance of the aircraft, and the autopilot crossbars for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies in the flight mode and zero with the autopilot and the auto throttle later and vertical navigation mode. We have also the HSI with the magnetic heading and track. You can see also the integrated display of the flight plan when we're gonna create it after a few minutes. I'm gonna use the one-magnet computer to input all the data of the aircraft for this flight. So I'm gonna create a flight plan or a flight path or a route. You can see it also in the navigation display, both in horizontal and vertical profile. So in the navigation display we have the terrain and weather reflections from the weather radar. You can see the terrain map with the airports, also the navigation aids, the board stations, the ADVS, the NDPs, the waypoints which are horizontal vertical navigation fixes. You're gonna have to transverse through some waypoints as we fly. So you will see how we're gonna do also that. You can see the displays here. So we'll start explaining you. You can see the navigation display. Also we have the magnetic north pole and the geographical north pole and the magnetic variation depending where we are in the world. We have also the wind direction and speed, the ground speed, the distance in nautical miles. You can see the terrain as I told you with red, green and yellow reflections, and also the sea, lakes and the rivers with blue. We have also the elevation difference because of the color difference code depending on the altitude that we're flying with respect to the terrain around us. You can see also we have here the airports with the 4-letter digit name over here. So you can see LFSB, LSZ, it's our own airport right now that we are located here, the magnetic heading also of the aircraft. So I'm gonna show you also, you can see the horizontal vertical profile of the flight run. I'm gonna create it in a few minutes. You can see also we have other displays, the autopilot flight director system panel, the flight management computer, the flight controls over here. I will start showing you how to use the flight controls of the Boeing 787 jet aircraft. So you will see how we're gonna use the flight controls of the Boeing 787 using the side stick, the Logitech Extreme 3D side stick that I'm using to control the elevator for climb descent, the ailerons and the spoilers for making bank roll turns left and right, the rudder pedals over here. The thrust levers also, you can use the thrust levers to move to actuate the engine's thrust or propulse the aircraft forward. You can see the engine's indications over here. I will start explaining it to also the left and the right engine, the limits, autopilot flight director system panel also over here. So you can see the indication, you can see the airspeed guidance, the heading guidance, the altitude guidance, auto throttle, left and right flight director, autopilot disengage, autopilot gauge and nav, later on vertical navigation, vertical rate of climb, descent and flight path angle, board localizer approach for autoland. You can see some other functions here, some displays for the systems. You can see you can set the barometric pressure over here, inches of mercury hectopascals. You see the barometric altitude, so you see the airspeed selected, and also the altitude selected are the same like the autopilot flight director system panel. Also the heading selected over here, 360 degrees. You can see the information that we have. You can see the airspeed indicated, the airspeed tape over here is gonna increase when we're gonna be flying. The altitude above the ground, the barometric altitude above the sea level, 1432 feet. For this barometric pressure setting, 39.92 inches of mercury. Radio minimums. You can see this needle here moves up when we climb and down. When we descend, it turns hundreds and thousands of feet per minute. The vertical speed indicator. Here's the pitch ladder decrease. 2.5, 5, 7.5, 10, 12.5, 15, 7.5, 20. Pitch up or pitch down. The bank angle. The flight director also bank angle decrease. Takeoff, go around. Flight mode annunciator. So you will see all these functions. All these modes will be different. Selected values after gonna make a few changes. So before going for flight. So you can see where we are located right now. You can see also the rest of the cockpit. I'll start explaining you all the systems. We have good view like this, good lighting view. So you can see I use the side stick for climbing, for descent, making turns left and right, the ailerons and the spoilers, the rudder pedals. We can use also the flight management computer later to create the flight plan. So I will input many data here and I create a route. You can see the keyboard, also the touch screen of the flight management computer of the Boeing 787, both sides, the captain, the first officer, also the mouse pad here. We can use for the cursor, so you'll see the mouse pad. It will appear here the selection we do with purple when we press something like a switch here. So you can see here. So you can see we can change the screen here using the mouse pad here. We can also select up here in the screens, also in the screens display. So I will show you all these things. I will make a full aircraft systems cockpit explanation, every system of the Boeing 787, also the overhead panel system, the electric, the hydraulic, the fuel system, the electronic engine control for the engines, the flight control computers. I'm gonna make an engine start demonstration, also the bleeder system from the engines, from the APU, and also the packs flow control for cabin pressurization, oxygen regulation in the cockpit, and wing and engine ADIs, and for the hydraulic fluid tanks pressurization. So you will see all the pressurization system of the aircraft, bleeder from the engines that we use for that. You will see also the integrated drive generator, the IDG that produces alternate current, the batteries over here. So you see all the systems in the overhead panel before we go for a flight. So I will talk to you mainly about the flight controls, how we can climb and descend, how you can use the horizontal trim stabilizer over here. You can see we have these switches. We can trim the horizontal tail up like this. You can see elevator trim left, click down, right click up. So you trim the horizontal elevator. You trim the nose of the aircraft up when you fly, and you give a pitch down effect when you do it this way. So this way it speeds up the nose, this the other way it speeds down. By moving the elevator up or down, it gives the aerodynamic effect. Also, you can use the alternate pitch trim here, the alternate channel from the flight control computers. So again, you can see nose up this way and nose down this way. Alternate pitch trim. You have also the parking brakes here, as you can see. You have the stabilizer cutoff switch here for the horizontal trim stabilizer. This is for all Boeing 737, 747, 757, 767, 777 and Boeing 787. If you have a failure, because we have also the auto trim function from autopilot flight director system panel, auto throttle, flight control computers, flight management computer. So you can see here we have the flight control computers that control the channels of the auto trim system. So if you have a failure of the hydraulics over here, it will affect the L2R2, it says, horizontal elevator stabilizer. So you have to open this and disconnect from normal to cut off the red carded switch. Then you have only the manual trim, so this disconnects the auto trim function. You have the manual trim all the time, alternate pitch trim here. for the horizontal elevator of the aircraft, the horizontal tail elevator, which balances the elevator tail. The manual channel always available, as you can see. Elevator trim, left click down, right click up. So we have also the head-up declutter over here, the autopilot disengage over here. So I'm gonna show you one by one all the instruments of the Boeing 787. So I will show you the flight controls of the Boeing 787. First, I will show you the outside view of the aircraft and explain you about the wings of the aircraft, the aerodynamics effects from the airflow when the aircraft is flying, also the thrust from the engine. So I'll talk to you about Newton's physics, aeronautical and aerospace engineering, Newton's physics and Bernoulli theory of fluids, and derive some principles we need to know for the air transport pilot license as well. So you can see here the outside view before explaining you the flight controls. So you can see here we have again the outside view, so you can see the wings of the aircraft hold the weight of the aircraft when the aircraft is flying, the forward wings mainly. You can see we have the minimum dynamic chord position, the Mach. About 23% of the minimum dynamic chord is where the maximum dynamic lift occurs in the wings. The center of pressure also can shift backwards when we fly, and also the stall begins when we fly. Over here the airflow becomes detached all the way back from the top surface of the wings, and we have the stall of the aircraft, so we need to avoid it for a given angle of attack and airspeed that is changing. So also you can see we have the minimum dynamic chord position here. It's also where the center of gravity of the aircraft will be approximately. Down here the vertical axis. We have the longitudinal axis from nose to tail and the lateral axis from wingtip to wingtip. You can see we have also the thrust vectors from the engines that move the aircraft forward from the Z engines. As you can see, we have the longitudinal axis. The lateral axis from wingtip to wingtip is the pitch axis. So the pitch axis, we can turn the elevator up and down and make the nose of the aircraft pitch up or pitch down around the pitch axis or the lateral axis, like this. As you can see also the horizontal tail moving up and down like this. When we fly, you have this effect over here. Also the rudder. So the rudder is the vertical axis through the center of gravity. Is also the yawing axis to make left and right yaw turns. We have also the longitudinal axis. That's the rolling axis. You make turns to the left and to the right through the longitudinal axis. That transverses also the elevator and the vertical stabilizer. So you make turns left and right like this using the lateral axis of the aircraft. So I will show you a couple more things now for the flight controls. So you can see we have also the wings of the aircraft that produce aerodynamic effects, and the flight control surfaces. You can see the bottom surface of the wings is more flat. We have also the flaps extended, and when we fly, the aircraft can be having a positive angle of attack. So we have using the Bernoulli theory of fluid, the airflow moves slower below the wings. So there is higher pressure below the wings, which pressurizes the aircraft wings up into the air with the weight of the aircraft through the thrust from the engines that move it forward. Also, you can see the top surface of the wings is more curved. So as we fly using the Bernoulli theory of fluids again, the airflow is moving much faster above the wings. so there is a lower pressure which sucks the aircraft weight and wings up into the air. Also you can see, so there is a differential pressure, higher pressure below the wings and lower pressure above the wings. You see also the spoilers extended now, the speed brakes of the aircraft can act also as roll spoilers in flight. So you can see the flight controls movement. So that was the explanation of the aerodynamics of the aircraft when we fly in Newton's physics. So we need to know a few more things. The flight controls. I told you the horizontal trim stabilizer, what to do with that. We have the effect from the elevator, as you see, climb and descent, the pitch axis. We have the lateral, the longitudinal axis for making turns left and right, and also the rudder pedals, the vertical axis. So he's using the rudder pedals like this to make young turns, all the vertical rudder. So it's quite simple. You can use all controls together or only one of them, only ailerons or elevator or rudder pedals. So you can see both sides are interconnected, the captain and the first off, so that they move independently from each other. Unlike in the Airbus, you have the side stick priority from each side. So unless you have a failure, they will move together in flight. All flight controls. Also, you can see the side stick deflection is proportional to the yoke. It's a fly-by-wire aircraft, so when you move the flight controls, you give a signal to the flight control computers. So you have normal, alternate. You can have the flight control computers here. Normal, alternate, and direct mode, like in the Airbus. You have also the rudder pedals. You control the vertical tail of the rudder at about 45 knots or higher in takeoff. You have also the nose wheel steering. The tiller 76 degrees decreases to like 7 degrees at 40 knots, then all the way up to 70 knots it goes to 0, and then you have on the rudder pedals for making directional turns in the ground. You have also the toe brakes in the rudder pedals, so you have a lot of controls over here. You can see also the thrust levers, so we have also the thrust levers over here in the yoke control in the side stick, actually the Logitech Extreme 3D that I control. The flight controls also control the thrust levers, so you see the thrust levers moving up. You see the engines indication, increase or decrease, gives a different information. So it will give you a warning that will not configure for takeoff, like this. So you see also we have the flaps and the slats, the auxiliary flight controls, the speed brakes. I will talk to you about that in a couple of seconds. Over here in the engines, you can see we have the fuel control, left and right engine fuel flow to the engines. You can turn off the engine fuel control. We have the fire extinguishers for the left and right engine, the transporter, the rudder trim, the radio management panel over here. So this is the pedestal of the aircraft also, where the engine's thrust levers is located. You can see also we have the thrust reversers, the takeoff go around switch over here, and the auto throttle disconnect here. As you can see, auto throttle disconnect and takeoff go around. So you press this switch here, you disconnect the auto throttle that you connect over here. Using these two switches, left engine, right engine. You see auto throttle arm. So we have a few more indications and things to see over here for the flight controls. So I will show you now the another view of the flight controls of the Boeing 787. Also the outside view. So you will see how I control them using the side stick to control the elevator for climb and descent, the ailerons and the spoilers to use the control wheel to make bunkers left and right, and also the rudder pedals for going turns using the rudder, and also for nose steering using the tiller in the ground, and also for toe brakes. So we have many controls in the rudder pedals. We have also the elevator control, the horizontal elevator control of the trim function of the elevator, the manual trim switch over here, and here the alternate tunnel. So I'll show you also this this view over here. So I hope you have a better view now. Really better view of the screen also. So you can see the side stick I'm using to control the elevator for climb and for descent over here. You can see we make turns left, turns right. Also rider pedals. So you can climb, you can descend, you can make turns to the right, turns to the left. Hope you like the side stick, the Lszh Extreme 3D over here that I'm using. You can see it's the identical with the Airbus. We have also the thrust control over here. Remove the thrust levers. You can see the thrust levers over here. Moving forward and after, very easy. And also the control of the flight controls, like these of the aircraft. So you can climb, you can descend, you can make turns to the right, turns to the left over here. So you can see the side stick deflection is proportional to the yoke deflection. Maybe not so good view now. A view like this. We have the horizontal trim stabilizer also. So hope you do like the side stick, the Lszh Extreme 3D that I'm using for controlling the flight controls, the thrust levers and the horizontal trim stabilizer, other functions of the Boeing 787. Also you can see another nice view over here outside. I'm at the sand, making turns left and right, aileron spoilers. So we have full flight controls like this, as you can see. So it's quite easy. Now we go for the rest of the systems. We saw a lot from the flight controls function. You will see also when we're gonna be flying how to use them. So I will talk to you a little bit more about the rest of the systems of the Boeing 787. So we have the thrust levers, the indications from the engines, the flaps and the slots. You can see also flaps and slots over here. It's fully extended, you can retract, it increases the surface area of the wings, you can make the aircraft fly at lower airspeed, you can set how many degrees you want, fully retract, Also now is fully retracted in the screen over here. It's up. So you can use it down like this. You can see now it's 15 degrees. So it moves down, it's in transition. So you will see also the outside view. The flaps now are moving down. You can fully extend them. So you can fully extend how many degrees you wish them to be. 18, 20, 25, 30. So you use the maximum for landing. You use like 5, 10, 15 for takeoff. Or less, like 105. So you see it keeps extending. Both sides are fully extended now. Also the speed brakes are extended, now retracted. So you see the speed brakes function over here. This handle. So this is the speed brakes, extend and retract, the thrust levers, left and right thrust lever, the flight control computers. You can see the screens here. You can see the landing gear is down, extended. We have the alternate gear. We have a failure of the normal. The lock override, the extend and retract speed here, the standby instruments display, the auto brakes over here. You can use rejected takeoff for maximum 1 to 3 for landing. So you see the auto brake over here display if you set it like rejected takeoff, auto brake RTO now it says. So we have also the gross weight of the aircraft over here for takeoff, and the fuel on board 34,500, 34,300 minus 5 C, the temperature of the fuel right now. So we have a few more things to see. Flight control computers over here, flight management computer, actually the head-up display also, we'll see later in flight. The overhead panel, so it's a few things only left. For us you can see the engines, left versus right engine indications. So we go in the flight management computer now to show you how to create a flight plan, and we input all the data of the aircraft for this flight, and includes the empty weight plus the passenger plus the cargo plus the fuel on board. Where the fuel is stored in the left and the right wing, we have 30% in the left and 30% in the right wing tank, 10% in the center tank. The flight management computer is going to calculate automatically the center of gravity of the aircraft from takeoff and all the way flying, cruise, climb, cruise, descent, approach and landing during whole flight. We burn fuel, so the center of gravity is shifted and is recalculated. Also it changes during the altitude of the flight of the aircraft. Also we have for takeoff we have the center of gravity using the takeoff gross weight, and the mean aerodynamic chord position. I told you the Mach 33% of the aerodynamic chord, where the maximum aerodynamic lift occurs. Also where the stall will begin in flight for given angle of attack. You can monitor all the time the stall speed over here. So you have the airspeed indicator, and you also have a warning when you approach the stall speed over here with a red and yellow indication. So you need to have an airspeed above the stall speed. So it will give you also the flaps for takeoff 15 degrees. The horizontal trim stabilizer 4.25 degrees going to be calculated also automatically using the mean aerodynamic chord position. And we're going to have the runway for takeoff in the Zurich International Airport, Lszh in Switzerland. We're going to have the runway length, the runway slope, the wind direction and speed, the barometric pressure, the density of the air, and the temperature of the air. Also the runway conditions, if they size dry or wet, they will give us the takeoff speed V1, V-rotate, and V2. So we're going to have also V2 plus 15 knots after takeoff, the green dot speed. We're going to have also the 9 degrees of pitch altitude or less for takeoff, and about 140-150 knots for takeoff. We're going to have 130 for V-rotate and 140 knots for V2. So we're gonna have the seats, the other instrument departure waypoints and fixes for the initial climb of the aircraft that will create a flight plan. The seats are the starter instrument departure waypoints and fixes that will also horizontal vertical navigation fixes and airspeed and altitude constraints the climb to the cruise level. We're gonna cruise like 35, 36, 37, 38, 29, 30,000 feet above the sea level. We're gonna transverse through some waypoints, also make some turns in the air. Then we're gonna begin the descent for the approach and landing. Descend back to the airport that we are beginning the flight. So we come back to the Zurich International Airport again for landing. So we descend to the stars. The stars are the star terminal arrival waypoints and fixes that include horizontal and vertical navigation fixes and altitude and airspeed constraints for the terminal approach and landing of the aircraft, and the long final and short final approach. So we have also we're gonna descend to like 7 or 6,000 feet above the sea level. Also we're gonna be aligned with the Lszh localizer, the horizontal localizer and the vertical glide slope of the runway. We're gonna use again the Zurich International Airport LCH in Switzerland. We're gonna receive the runway radio frequency from the radio transmitters from the antennas of the runway threshold. Is gonna receive from the aircraft on board the antennas and will display the localizer, horizontal localizer with the runway magnetic north pole heading of 136 degrees. For this runway we're gonna use for landing. Also the vertical glide slope, we're gonna descend using the glide slope. We're gonna have also the Lszh localizer frequency tuned either automatically using the flight management computer or manually using the radio management panel. We're gonna have the Lszh localizer closed, but we're gonna have the flaps set for takeoff 25 or 30 degrees. We're gonna have an airspeed 160, 170 knots for approach and landing, and a pitch altitude like 9 degrees or less until the touchdown in the runway 14 in Lszh in Switzerland. We're gonna see also that we're gonna have the landing gear down, and this is all for the flight plan. So control quadrant, so you'll see how I'm gonna create now the flight management computer over here. This section you'll see also we have the mouse pad as I told you here. So I'm gonna use the flight management computer here. You can see the commands over here of the index. You can see identity, position, performance, takeoff, approach. You can see I'm using the mouse pad now to control this. I have also the keyboard here. So I have the identity model 787-900 GNX NZ. So it's a Boeing model. We have the position, Boeing 787 with position is Lszh. The coordinate GPS alignment, also gyroscopic alignment, performance, the takeoff gross weight, 0 fuel weight plus fuel on board is going to give us the gross weight for takeoff. We're going to set the cruising altitude also and other information. So we're going to start with the route from this airport Lszh in Switzerland back to this airport Lszh to Lszh back. Over here departure arrival, clear that discontinuity, runway 14. So we have the information, the initial information over here. I'll tell you also the mouse pad. So we use initialize route departure arrival. So we set departure for this. We can set runway 10, 16, 28, 32, 14. So we select runway 14. And the seats, the southern instrument departure, waypoints and fixes, route to Alpha. So we set then arrivals over here. VOM 16, 28, 34, ILS 14, ILS 16, ILS 28, ILS 34, GLS 14, localizer 28, localizer 34. So we're gonna set ILS 14 for approach and landing, trans Amity for the descent. Also the stars, the starter terminal arrival, waypoints and fixes on the left side. I'm gonna use the Negria 1 Alpha. So we have the stars and the arrival. So the legs now are created for the route. You can see the route is with blue, is not yet active. so we need to activate that. You can see the first, second, third, fourth, fifth waypoint will continue for the climb. So this is the legs of the route or flight plan or flight path of the aircraft that is going to be following horizontal and vertical all the way down here to approach and landing. So we need to set up now zero fuel plus fuel on board 322.7 plus 33.9, gross weight 356.6 thousand pounds, reserves 5%, cruising altitude 25,300 feet over here, cost index 100%. It's gonna give us also the fuel freezing temperature. You can see in flight the fuel will freeze that we have over here. We reach minus 37 degrees. Also you can see the center of gravity here in flight, the cruise altitude 25,300. So this is all the calculations for the performance. We're gonna use here the execute button here is gonna activate the flight plan, the legs over here. So we press execute and you see the purple now. We have an active route. From takeoff, first waypoint 334 knots, 1902 nautical miles, heading 135 degrees. Then cross 1, 2, 3 waypoints, 1356 nautical miles away, Zui, 324 knots, 6000 alpha, 052 heading. So then we make some turn, Nigra 071, 36 nautical miles, Mach 0.76, 35,300, Mativ 230 degrees, we make a right turn, 12 nautical miles, Mach 0.76, 35,300, Amity 258 degrees, 6 nautical miles, 190, 25,300, then we descend, Zui 276 degrees, make a small turn, 9 nautical miles, 180 knots, 7,000 alpha over here. So you see all the waypoints and the airspeed constraint Z701, 6 nautical miles, 180 knots, 6,000 alpha. Here's the stars, it's the terminal arrival waypoints for approach and landing. TRA 290 degrees, 10 nautical miles, 180, 5,000 alpha. CI 180 knots, 4,000 alpha. Then we turn to the runway heading 136 degrees in the Ocean waypoint, 5 nautical miles, 324 knots, 4,000 alpha. Runway 8 nautical miles, 136 degrees, 8 nautical miles away, 1,430 feet. Then we have takeoff, go run. So this is all the route. We need to use flaps for takeoff, 15 degrees. Over here, center of gravity. So flaps for takeoff, 15 degrees, center of gravity 33%, 4.85, V1, V-rotate, V1, 128, V-rotate 130, V2, 140, gross weight, takeoff, ground, runway, length and position. So this is for takeoff. We have also a few more information, the route alternate over here, alternate route, VNAV progress over here. So you have VNAV progress, FMC communication hold, you can hold over a waypoint here in flight, the legs, fix, you can hold, set up fix and radio navigation over here. So this is the very important things you need to know about the flight management computer. Now we'll show you the engines functions, the autopilot flight director system panel. We're gonna make a complete flight, we're gonna make the engine start demonstration, so we need not to lose time. So you can see the flight plan here displayed. Also you can see the runway and the taxiway, the other runway where the aircraft is located. In the GPS receiver you can see the terrain in front of you when you're flying. So this is for navigation purposes. You can see the terrain, how far above the terrain we will be flying. You can see the flight plan we have created. Over here you can see the indications, the terrain elevation, also top of climb, top of descent. So we'll change a few more the range over here. You will see for climb here cruise, descent, approach and landing. So I will show you further away, you'll see more waypoints, also the center display. You can see the whole flight plan for takeoff, climb over here. cruise descent, approach and landing all the way up. Also the vertical, one waypoint by another, but we have to fly through using the waypoints here, the legs as you can see. So we change the range, you will see closer, the waypoints now are better view. One waypoint by another over here, the purple of the flight plan, descent, approach and landing. Also we can use other this scroll view. We have also other settings here, other displays. The plan also display over here, map setting, as you can see. So you can see we can display also weather, traffic, terrain, change the range over here in the plan. Our displays minimums and barometric setting. So we'll talk to you about the navigation displays that we use in the Boeing aircraft. Pretty much identical to all aircraft. You can see how far away we will be flying over here, the furthest away waypoint. You can see also some airports here further away. Also here you can see Germany, France, Switzerland in the terrain map. So we'll look closer. You can see the airspeed again, altitude, barometric altitude. So we have the air data computer over here, controls, monitors and displays, pitot static, pitot barometric, laser gyroscopes, GPS receivers. So the dynamic airspeed and barometric altitude are set from the air data computer. Also the attitude, laser gyroscopes, other things, angle of attack as we fly, temperatures, pressure. So we have also over here we can see the engines indications. We have the N1, which is the low speed starter sub, low pressure compressor, and turbine of the turbofan, which is engine left and right, the exhaust gas temperature per engine. The N2, which is the high speed starter sub, high pressure compressor, and turbine of the turbofan, which is engine, fuel flow per hour, 1000 kilograms, 1000 pounds, oil pressure, oil temperature, oil quantity, and the vibration of the N2 stage of the engine. So we can set also the cabin pressurization here in the manual. You will see what happens over here, manual setting. So we have the FADEX. The FADEX are the full authority the electronic control computers, one installed per engine gearbox. We have the GNX jet engines. So the FADEX control monitors and display all the functions you see in the upper and lower ACAS, like the N1, which is the low speed starter shaft, the low pressure compressor, and turbine of the turbofan engine, the exhaust gas temperature per engine, the N2, which is the high speed starter shaft, the high pressure compressor, and turbine of the turbofan engine, the fuel flow per engine per 1000 kilograms, all the pressure, all temperature, and quantity, the vibration of the N2 stage of the engine, the pressurizer from the left and the right engine, from the 5th and 9th stage for cabin pressurization, weaken engine, anti-ice, air conditioning, ventilation, hydraulic fluid tanks pressurization. Also the FADEX control the fuel recirculation from the wing tanks, from the left and the right wing tank and the center tank to the engines for heating up the fuel in flight so it won't freeze. Also the lubricant and the oil. So we have the oil and fuel recirculation system automatically from the FADEX. Also as we climb from the sea level, and we climb higher to like 20, 30 or 40,000 feet above the sea level, like 8,000, 9,000, 10,000, 11, 12,000 feet above the sea level, meters above the sea level. As we climb higher, the pressure of the air, the pressure of the air, the oxygen level and the density of the air become less than half than that of the sea level. Also the aircraft will be flying with an airspeed rate like 2 or 3 times faster than that of the sea level. Also the temperature will be coming freezing, like -30, -40, -50, -60 degrees below zero. So as we're going to be flying faster at higher altitudes and the air is thinner, we're going to have a different fuel air mixture request to be adjusted every second automatically from the FADEX. This is also done automatic, the fuel air mixture request. Also vice versa as we descend back to the airport elevation from like the cruising altitude. So it's a good thing to have the FADEX installed into your engines. Now I'll show you a little bit more the overhead panel. You can see here we have the APU. We're gonna start the engines here. So we need the APU, have the contactors left and right IDZ, 130 200 volts, 400 Hz frequency, primary flight control computers at the auto position over here. You can see flight control surfaces, your data computer, FD, door power, towing power, passenger oxygen over here, window heat. We have the rammer turbine, hydraulics, left and right engine driving, primary in demand. See what happens when you turn off. We have the electric also, so we turn back on, then to the auto position. We have the wing and engine DIs over here, as you can see, on, then back to the auto. We have the lighting system, windshield wipers over here. We can see also here we have the recorders, we have the cargo and APU fire. Over here we have the electronic engine control for the engines with the auto start, normal and alternate mode. Electronic engine control for the engine. We can dump some fuel in flight, the fuel jettison. We arm the switch and select the nozzles, how much is remaining, make an emergency landing. We have the right wing and the center tank. Crossfeed valve is off, but we turn it on. You can feed either engine with other pump or either tank. You can also balance the fuel between the left and right wing tank over here. So you can see the fuel system. You can see also the pressurizer from the left and right engine, from the APU, from the packs, and also the outflow valves, cabin pressurization in the manual. Also in the auto we need to do nothing, it's automatic. So we have one more thing to do before making an engine start demonstration. Set the lighting here. We're gonna have the engines, we're gonna have all the systems indications over here. So you see whatever is in the overhead panel. We have the hydraulics over here. APU is running, oxygen, liquid cooling. So you see the electrics, left and right engine, hydraulic and IDG, the great generator, 120 to 100 volts, 400 Hz frequency, the APU, battery voltage and APU battery, load set, how many volts you have from the batteries. So you see the generator drive over here. So this is the electric. You have the hydraulics over here, where the hydraulic fluid goes, left and right engine, C1, C2, electric driving, 5000 psi, it's left, right, center, primary demand, start-off valves, fuel on board. You have left and right wing fuel tank, insider tank, 11,000, 11,000, 10,000, 11,000, 33,300 in total. Low and high pressure fuel valves, left and right engine, are open and feed both left and right engine. The crossfeed valve is off, but we turn it on, you can feed either engine with either pump or either tank. The APU is fed from the left wing using DC motor. So you can see also we have the minimum fuel temperature over here, minus 37 degrees, below which the fuel will freeze in flight, and the fuel temperature right now. So we recirculate the fuel automatically from the FedEx control system. So we have the air pressurizer from the packs, from the engines and the APU. Doors are closed, the cabin can be pressurized, the landing gear, the pressure of the tires and the temperature of the brakes, and the nozzle, the flight controls over here. So you move the flight controls around, you will see what happens pretty much like this. You see all flight controls are moving as they should be, in the wings, left and right wing, the tail of the aircraft, the elevator trim, the limits. So we have also the FS display over here, maintenance, circuit breakers over here, also digital circuit breakers, checklist, last thing to do before flight. So we have the checklist here. You can see normal menu, what to do before start, after takeoff, approach, descent and landing. So we have the communications, navigation display. So very quickly we need to make the exit start demonstration. So we turn off both fuel control, left and right in the off position. You will see what happens. We'll have the warnings here and the engines are going off. So we need to restart very quickly. Over here the engine auto start, both engines in the auto start, left and right. You see the reconfiguration of the overhead panel, with amber color. We're gonna have the APU pressurizer admitted into the engine starter, left and right, both of them. So you see 19.20%. Above 20% we have enough pressurizer. You can hear the roaring from the pressurizer. So we can start the fuel flow to the engines, both of them. So we start the fuel flow very quickly. You see what happens. We have the auto start on over here. So we have also the hydraulics coming back to life. The flight controls, also the fuel pumps will go off. So the engines are on, almost running. Auto start. So now both engines are running left and right. We can go for takeoff like this. So we use flaps for takeoff. Also set over here a couple of things. Heading, we're gonna use the heading in the autopilot of the runway we're gonna use for takeoff. 136 degrees over here. We're gonna set also the airspeed, the altitude over here, and the vertical speed. We're gonna set climb here. We can set also descent. So the autopilot is set, parking brakes off, and we taxi into the runway. Advance the thrust levers. So the runway is open for us for takeoff. Just use the tiller here for nodal steering. We take the runway clearance from the air traffic control. We're gonna be aligned with the runway center line here. So advance the thrust levers to full takeoff, go around power. So hold the yoke a little bit down, just like in the Airbus, until 100 knots. So we have 100 knots, 120, V1, we rotate slightly, like 9 degrees. So we have the takeoff, positive rate of climb, pitch altitude a little bit higher. So landing gear up. So you can see here all the information that we have right now, the terrain, also below us, around us, if we look closer. You can see we are 1,000–2,400 above the ground, 4,000 feet above the sea. Need to pitch down a little bit the aircraft. So you can see here the airspeed right now, 164 knots, the pitch altitude 70 degrees. We climb with 3,900 feet, cross 6,000. You can see the terrain below us over here. How far below is the ground as we find the engines indication. So this is the cockpit after takeoff over here. So look outside also. You see the runways here after takeoff. So this is a beautiful view of the Switzerland, the lakes here, and we're gonna make the turn now for the airport, for the flight plan. To follow the flight plan. So we're gonna cross through all these waypoints over here, as you're gonna see in the flight. We have to cross through all the waypoints, the intercepts over here. Make a left turn, then a right turn. Let's climb. Transverse through the Zui over here. So you can see also the outside view as we've been flying right now. Very beautiful. Also the galactic view. So we have the France here, the Switzerland, the Germany, Bayern Munich in front of you. It's a very nice view. Need to make the turn now. You can leave the controls off like this if you are trimmed right the aircraft. If you have trimmed the aircraft the way it should be, there is no problem. So we need a few more minutes to come back for landing. As you can see, you can see how far away we need to fly over here. So make some turns. So we have a very nice view of the cockpit here, all the instruments, the Boeing 787 as we are flying. So we cross here 19,000. So we need to be aligned now with the waypoints, with the flight plan here, as you can see. have the next waypoint here, the Negria. You can see the wind speed direction, this vector. So we're gonna start maybe turning now in a couple of minutes. We're flying 30,000 feet over here. So we have again the France, the Germany, my homeland, the Bayern Munich in front of you, the lakes, the Switzerland here, the galaxy, and the Swiss Alps. So we're gonna make the turn now. As we climb, we're gonna make the turn. You can see how we turn. We can level off, no problem. You can see the flight plans that we follow. Over here, the flight plan. We need to make a turn now. So if we look outside, you can see the Germany, Bayern Munich, the lake, the France, the Italy in this side, and the Swiss Alps. Beautiful view of the Swiss Alps. Also the aircraft, the Boeing 787. So make a little bit more steep turn now. Yes. Έχει κρύο. My dogs. So we need to level off here, as you can see. Leveling off manually. I'll fly manually, as you can see. So we're gonna have the chemtrails now, beautiful chemtrails, frozen vapors from the aircraft tail, from the engines actually. So you can see the Germany again, France this way, frozen vapors with the lake. So we're flying almost 34,000 feet, 34,800. So hope you like the view from the aircraft from 35,000 feet approximately. So we're gonna start the descent now. We have 6 more minutes left. Gonna increase the airspeed, flaps up, and start the descent here. So here we are, keep having the chemtrails while we descend. We accelerate also. You can have the airport location over here where we are located. So you can see the runways in a couple of minutes as we're going to be approaching here. So we're gonna start the turn in a couple of minutes. You can see we need to follow all these waypoints here as we are descending. More idle thrust now. You can see where the runway is located over here. The idle thrust we have in the engines. Also, we need to keep descending. We begin the turn now as we are descending. Keep descending over here, having 1 minute more for a line with the runway. We need a little bit left rudder here as we turn. So we have a few clouds, also line with the runway heading. So increase a little bit the rate of descent over here. So we have a few more, 2 more minutes actually left for alignment with the runway, as you can see, for approach and landing over here. So we have the runway inside. We got some delay. So keep descending. We have some wind gust. We need to align with the rudder pedals to avoid the wind gust over here, the gust in wings, and the side wing. So it doesn't help us to align with the runway. So we're gonna have also this view for approach and landing over here. And we have 1 more minute left for approach and landing over here. You can see we have the Lszh localizer. Over here we need to follow the Lszh localizer indications. Also we have the runway in the middle of the display. We have 30 more seconds to go for approach and landing before the video will actually end. So we need to increase the airspeed a little bit as we are descending. So perhaps we won't record the landing point. So we need another 10 seconds to reach the landing point here. Here we are, almost reached the flare point, idle thrust. Here we are, touchdown, parking brakes and thrust reverser, idle thrust and thrust reverse. So here we are, just landed, very beautiful landing.